whenever I'm dealing with a 3 by 3 system, okay, so if I have 2x plus 3y plus 7z equal to negative 3, and then x minus 6y plus z equal to negative 4, and negative x minus 3y plus 8z equal to 1. Again, you can do it by substitution if you would like. Okay, that is okay. But personally, I think that it's a little bit too risky as far as too many ways to make a mistake. Okay, so that's why I would stick with elimination here. Because I think just over the span of time of teaching this, that it seemingly is that students can figure out, they're more comfortable with elimination, along with it's a little bit easier to basically get it down from 3 variables to 2, 2 variables to 1, and then start plugging things back in. Okay? So as far as your steps are concerned, it's really quite simple. You start with 3 variables, you're going to work your way down until you get to 1 variable, and then you're going to start plugging, kind of going back in reverse order. Okay? So what that means is, if I have the example here, what is probably going to be the easiest variable to get rid of with the least amount of work? X, right? Now, in doing this, I'm going to have to use one of these variables, or one of these equations, twice. Okay? So what I usually do, okay, and you'll see it on, if you go back and look at I usually give them names, and I just call it A, B, and C. Okay, I don't like to use 1, 2, and 3, or 4 and 5, because then it's like I've got an extra number out there, whereas A, B, and C, I can say, okay, this is what I have. There's going to be one of these 3 that I'm going to use twice. Okay, I'm going to use one of these twice to figure out, because I want to basically get rid of the x's in each problem. Okay, and what it's going to do is it's going to create like an equation D and an equation E, and then I'm going to put those two together, and I'm going to eliminate another variable again, like we did the last couple days. So what is the first 2 that I would, if I want to eliminate the x, okay, if I want to eliminate the x, what are the first 2 that I probably want to put together? B and C, right? So what I'm going to do, I'm going to have B, and I'm going to have C, and I'm just going to rewrite them how they are. Do I need to change anything to get rid of the x's? No. So I have x minus 6y plus z equal to negative 4. And then I have negative x minus 3y plus 8z equals 1. So I don't need to do anything here. I'm just going to add everything straight down. And whenever I do, the x's cancel. I'm looking at negative 9y plus 9z equal to negative 3. Is everybody good with what I've done here? Okay. I eliminated the x's. That's one step. Now, which one didn't I use? A, first one, right? So I'm going to have A here. Since I didn't use A, I'm going to use A now. Okay, I'm going to give myself a little bit more room. And I'm going to have 2x plus 3y plus 7z is negative 3. Now, which one? So again, like I said earlier, you're going to have to use one of these twice. Which one do you want to use again? Okay. Now, what do I have? That's fine. Now, if you want to use c again, what do I have to do to c to where the x's are going to, or the coefficient in front of it's going to be the same? What is it? It's going to multiply by 2. So what I'm going to do, I'm going to write 2c here. Okay. Why did I write 2c? Because I'm going to multiply everything by 2, right? So I'm just going to take everything here. It just saves me kind of an extra step. So then I'm going to have negative 2x minus 6y plus 16z equals 2. So now, do I have to change any signs? No, right? Because they're going to cancel here. So then I'm looking at negative 3y plus 23z equal to negative 1. Well, negative 3 plus 2 is negative 1. I'm just going to give them their own values. I'm just going to call it D and E. Okay? You don't have to give them names. I just give them names so then I know which one I can look at. Okay? It just kind of helps. I think it helps students to see, all right, we multiplied C by 2. Now we have our new functions. We have D and E. Now, what's going to be, again, the easiest one? Okay, now it just goes to a 2 by 2, right? We have Y and Z. Which one's going to be the easiest one to get to match? The Y or the Z? The Y, right? Now, do we have to do anything to D? No, okay, because it's negative 9. Okay, the other one in E, or my orange one, or the E, or whatever you want to call it, it's negative 3. So I can just manipulate that one. I don't have to do anything with the green one. So I'm going to have function D, which is just going to be negative 9y plus 9z equal to negative 3. Now, what do I need to do to E to where they're going to be? What do I need to do to it? Multiply it by 3. Okay. So I'm going to multiply E by 3. So I'm going to have 3e. So in doing that, I'm going to have negative 9y plus 69z equal to negative 3. Now, what do I need to do to get the y's to cancel? I need to subtract, or I need to change every sign on the bottom side. So it's going to be a plus, it's going to be a minus, and it's going to be a plus. So now the 9y's go away. I'm looking at 78z equal to 0. So what is z going to be equal to? 0. So there's one part. Yes, it should have been negative 60. But does that change our answer? No. My fault. Once I get one value, now all I'm going to do is I'm going to plug in z equal to 0 to either equation D or E. It doesn't matter to me which one you do, but it's going to go either into the orange one or it's going into the green one. So which one do you want? Does it matter which one we plug it into? No. Which one do you want to plug it into? Okay. So if we, we should get the same answer. Okay. So it doesn't matter if I plug it into the green one or if I plug it into the orange one. So if I take it and I plug it into, what do we say, D? So I'm going to take it and I'm just going to plug it in right here into my function D. So I'm going to kind of work backwards. So negative 9y plus 9 times 0 equals negative 3. So 9 times 0 is just 0. So I have negative 9y equals negative 3. Now what? Divide by negative 9. Y is equal to 1/3. You get 2. Now I'm basically going to, I'm going to plug in z equal to 0 and y equal to 1/3. 2 into an original equation. It doesn't matter to me which one you plug it into. But, again, work smart, not hard. What's the smart one to plug it into?
The first one.
Okay, plug it into the first one. I'm going to plug it into the second one, though, because...
Plus 1 equals negative 3.
Well, that's fine. But I just already have an x there. That way I don't have to divide anything. You know what I mean? You can do it, again, it doesn't matter which one you pick. You can pick A, B, or C. As long as you pick one of the originals, don't pick anything that you manipulate. Always go back to the original once you have 2 variables. So once you have 2 variables, go back to an original. I don't care if you go A, I don't care if you go B, I don't care if you go into C. Okay? I'm going to go to B because it's X. And I don't have to do anything. I just have to plug it in and then move my values over. So all I'm going to do is take x minus 6 times 1/3 plus 0 equals negative 4. So I have x minus 2 equals negative 4. Add 2 equals negative 2. So now, just like we did whenever we had our system, I'm just going to write it as a coordinate. So I'm going to have negative 2, 1/3, and 0. Visual representation. We already did one that has one solution, a plane where they intersect in a single point. Okay? Just like whenever we had a 2x2, I'm going to kind of go backwards. We have an infinite solution. Those are 3 planes that intersect in a single line. Okay? Basically, everything's going to work out to be the same. And then no solution or where you're going to have 3 parallel planes or 3 planes that do not share the same intersection point. Okay? So it's still going to work out to be the same thing. If it's no solution, then you get an equation that is basically not true. So if you get an equation that is not true, what that looks like it's going to be like 0 equals 6. 2 equals negative 4. If you get an equation that is true, so if you get something like 0 equal to 0, 2 equal to 2. Then you're going to have infinitely many solutions. Okay? So if you get something that it works out and you end up getting, or things just cancel or they go away, and you end up with 0 equal to 6, then it's automatically, you can stop right there and it is no solution. Again, if you get one that everything goes away or whatever, and you end up with 0 equal to 0, 2 equal to 2, and it's a true statement, then you can be done right there and say it's infinitely many solutions. You want to see another example, or do you want to go?